So hi everybody and welcome back to SAS C++ tutorial series for absolute beginners. This is video 349 and in this video we continue again with the move assignment operator, and like all time here in CPP reference.com you click on language, here in classes to the move assignment operator. Okay, and here we have the implicit declared move assignment operator, and again you can read this one. I skipped this reading here and we jump to the next one. It says here implicitly defined move assignment operator. So this is here the declaration, here the definition. Again, you read this again. And I am jumping here directly to the examples here. Okay, what we have here is first a struct, which is called v. Okay, the struct has just defined a move assignment operator here. This one we learned already the syntax. Here's the return type, the operator overloading, the parameter list, and the function body. Perfect. And we are returning just the this pointer, and we already all know what this is. This is the hidden this pointer, which every struct class and so on have defined. And we're returning it with the asterisk, which means we are returning the object itself back. But let's read also this comment, because this is a little bit irritating, because it says here this may be called once or twice. If called twice, other is the just move from v sub object. Okay, we will talk about this one later, but let's go on. First of all, we create a new struct called a, and what we have here, again, this is inheritance, but interesting is the word virtual here, because virtual inheritance means what? Okay, here a reminder, when we talk about inheritance, there are different kind of inheritance. One is an inheritance with the word virtual, which we see here, and one is without this word virtual, which we can see here on the other side, this non-virtual inheritance. And the difference is, if we use the word virtual like here in our example, then we are just creating one base. In this case it's called v, our base v, and when we create another struct b here like this one, and we use again the word virtual, then it will again create only this one base, so it is sharing the one base which they have. And when we compare this now to the non-virtual inheritance, then you can see, for example, a in our case would then inherit from v and create a separate v base object, and then b would also create here a v base, also separate v base object. And here a side note, don't mix virtual inheritance with the word virtual with functions, because these are two separate things. Virtual with function is more related to polymorphism, which has nothing to do with virtual inheritance, which is related to the base class. And now we can also see why they mentioned here in this example that the move assignment operator could be called once or twice, because we have here virtual inheritance. V is the base object, and A and B here are inheriting from V, and they could call this one here two times, and this can cause problems. Okay, let's continue with our example. Here we create struct A. Okay, virtual inheritance. Okay, the body of the struct has nothing in it, which means the compiler may create an implicit move constructor, and in the comment it is noted that then the compiler will call v operator, which means the base move assignment operator here with struct A. And when we go on, struct B has also virtual inheritance, so A and B shares this base v. We can see this now, but again the body of the struct has also nothing in it, so the compiler may create here also the move assignment operator, and then it will call also the move assignment operator later from the base v, and that's why they called here, this may be called one or twice. Calling twice, it's a problem. We will see this later a little bit more in detail. Okay, and let's go to the next, which is the struct C. And in struct C we have a normal inheritance, which inherits from B and C, A, which we have created here. And then again the body is empty, which means the compiler may create again implicit move assignment operator. And here in the comment it says the compiler compiler will call first B operator of assignment operator, because we have the B inherited here first, and then the A assignment operator. Later it will call this, and this we can see now will cause a problem, because they may be called once or twice. Once is okay, twice is not okay. Okay, and let's jump now to the main. So we see here first we are creating two C1 and C2 objects, which is from the struct C. Important here note, remember we create this first, and then after we created them, we use C2, which is already created here, and then we want to assign C1 to C2. Okay, what happens here again? First of all, we take C1, which is an L value, a named value, but we want to use move semantics, which require R value. So we convert an L value here to an R value. And how we do this? With std_move. We already know this, so this one will cast it to an R value, and then we can use move semantics because the definition requires here an R value parameter, and we have created this one. Okay, now with std_move and C1 we created an R value, and we try now to assign this here to C2. And remember, because C2 is not an object creation, because it already exists, the move constructor will be not called. Instead, the move assignment operator will be called. And now we check, when we try to assign this one to C2, what we do all time, we jump to the class, in this case the struct C, we check the body and we see there is nothing, but we already read here a little bit, implicit declared move assignment operator and the implicit defined move assignment operator. If the requirements are met, the compiler will create this one and use it. Okay, in this example, the requirements are met and the compiler is creating the move assignment operator for C, and the move assignment operator for C will then call the B's assignment operator and later the A's assignment operator. Okay, then we jump to B because this one is called first, and B is empty as well, but the requirements are met again. So the B assignment operator was called, and B will call then the V assignment operator. And the same goes for struct A, because C has called A's assignment operator. Then again, it checks the requirements for struct A. Yes, it's met. And then the struct A will call with his assignment operator the V assignment operator. And because it's virtual inheritance, this V here will be called 2 times. Again, here's the diagram. A will call this one, B will call this one, and who calls first gives his data here in, and A will give then later garbage data and overwrite that what was given in by B. And when we compare this one here, what we have in our example with this virtual inheritance with this non-virtual inheritance, here we would have no problem because A has its own base V and B has its own base V. So in our case, we have a problem here. And I want to show you this also here in the compiler explorer. We get here a warning. It runs, but we get just a warning that here the assignment operator of B and the assignment operator of A is calling indeed, in this case perhaps, the virtual base 2 times, which will cause a problem. But for us beginner, this is even a bigger problem because the compiler is not showing an error here, but in the end we can create here garbage data, which is not useful for our program, and we don't understand why our program has this wrong data, even there is no error in the compilation. There are different kind of solutions, but the simplest solution is just to try to avoid move semantics with virtual inheritance, because then this kind of stuff can occur. But if you still want to use it, then you have to make sure that the compiler will recognize that there is a possibility of 2 calls, and then you have to handle this internally here. Okay, and let's jump back to the last part, and we see here the V move assignment operator will be called like we talked perhaps 2 times, which will cause a problem. But the move assignment operator here is nothing doing really, just returning this with an asterisk, which means we are returning the object here itself. And this one is used mostly for chaining, for object chaining. For example, you want to write C equal C2 and then equal C3. And this is possible because we make here object chaining and we get then this here. But this is enough so far, because we will watch later the examples here below where we see a little bit more concrete numbers to see what's happening and not. And I think that's also enough for this video. And like all time, if you have any questions, write in the comment section. See you in the next video. Bye and good luck.